now we will put it all together. And to do this, what we want to do is kind of put everything in our problem together. So I'm going to start off with doing it in different colors so that by the end we're going to have one final um, graph that will be at the very end of that will be the final graph. So here I start with my plus 3 because I want to start with the what the y values will happen, which will be the up and down. So this right here will be up 3 units. All the y values are up 3 units. Then I'm going to I remember that I have this minus here, and I notice that this is a plus, so this has to be subtract. So I want to kind of change it to a subtraction. So my number is a -1 because a -1 minus 1 or minus a -1 is a +1. So it's still the same equivalent equation, just the form is different. So that means that this is my left and right horizontal change. So that means the -1 is a left 1. So that's all points. And we'll focus on the vertex, but all points are up 3, left 1, and now we're going to look at the number 2 in front. So that number in front that means all of those y values are going to be multiplied by 2. So y values times 2. And lastly, I'm going to do that negative. And this is that reflection. So reflect. And I did it in red so that at the very end, that will be our last one. So I kind of did this in a specific order. I started with my y values just because those were a little bit easier to kind of think about it first. And then I went from that one to my x values when they're moving left and right on the x, or not the x values, but yeah, with the x. Then I multiplied y values vertically, that times 2, and then that reflection. And we'll come back to that reflection at the end and talk a little bit more about that. So I'm going to take all of these points and we're going to go up, and I'm going to focus on that vertex because that's kind of like the main point of the absolute value function. So I'm going to move that point up 3 units, and then I'm thinking all of these points are going to be moved up. So this line, all those infinite number of points are going to move vertically 3 up 3. So I kind of going to use this point now to kind of get my over 1 up 1, over 2 up 2, over 3 up 3. So I see that my line becomes up here and then left 1 up 1, left 1 up 1. So I'm still using that same concept of the absolute value function to get a more accurate or easier way to graph that absolute value function. So this is my first kind of move. So I'm just going to kind of, my line is a little off. So it's my rough draft. So I'm going to just kind of rough it in. You should be using your ruler to do this. So that's my K, or my last number. So now I'm going to do the purple, which is my left. So I'm going to take that same point, and move it left 1 unit. So that's my horizontal change. I know before, if we just had it by itself, it was down here, but we were doing this as a whole group together. So we're going to go up 3 first, left 1. So I'm going to use my points of reference to kind of get that absolute value kind of picture in my head where it's moving. So I want it up there. And remember again, you're kind of using, now notice that I'm doing it kind of lightly. So these are not my final positions. So if we looked at just, if we didn't have that -2 in front of our absolute value, then that would be our final, the purple would be kind of our final end of our graphing. But because we have these, we have two more things to do. So when we go to the y values being multiplied by 2, that means starting, not from our x-axis, but starting from this horizontal line, right there on that vertex, we're going to go, instead of being 1 up, it's now going to be multiplied by 2. So that would be a 2. 0 times 2 is 0. If we went over 2, the normal absolute value function would be 2 up, but now we're going to double that y value to 4. If we go over 3, it would be up 3, and that doubled would be 6. And we will reflect that same idea over to up to, which would be doubled would be 4. Over 3 would be 3 up, and then doubled would be 6. And that would be our times 2. So I'm going to do another rough one. And I notice that it's narrower than the parent function. And then our last one is the reflect. And this is, we're going to reflect in a certain spot. And we'll talk about that in a second here. So that reflection, if we reflected it across the x-axis, that means it would be down here facing kind of down in this area over here, and that is not going to be the right place for that. So that reflection, let me get rid of these lines. That reflection is actually going to be reflected across this horizontal line, and the equation for that line is y equals 3. So we're going to be reflecting it across y equals 3, not the x-axis. So that reflection, well, at 0 would reflect on itself. This point that was 2 units up will now be 2 units down, that negative. Now this one would be 4 units up, so it would be 4 units down. 6 units up would be 6 units down. So if I start at the 4, I can count 2 more down. Then I can continue on and continue that pattern all the way towards the edge. Now this will be my line on one side, so I have to do the other side of my absolute value. So 2 away from that line of reflection. So 2 down, 4 above the line of reflection. So we're going to reflect it. That negative will reflect those y values into the negative, not the negative numbers, but the number of values up there. So 6 being the positive side, the opposite would be 6 going down the other side, 8 going down, 10, and then 12. Now we will take our ruler and spend some time to get a nice straight line in the right place. Now that should have gone through that point right there. It's a little tricky for me with my computer board, but when you do it on your paper, it's a lot easier. You have to go right through that crosshairs. All right, there we go. That one's much better. All right, and I'll make a nice dark line so that that is our final graph of, and I'll write it right here, y equals -2, the absolute value of x, plus 1, and I'm thinking in my head minus a -1, close absolute value plus 3. So that is graphing a more complex, the different pieces, like 4 different parts of graphing absolute value functions.